Hi all, I am Vijay Jethani. I'm Cloud Solution Architect at Microsoft. So this session is all about how we design service-oriented architecture and microservices. So we will also touch upon the development aspects because that is what is required for this session. And if you have attended my previous session, we covered from the developer tools aspects and what developer required on cloud. So bare minimum, you have to have understanding of the monolithic architectures and how we move towards the service oriented and microservice architectures. So these all aspects will be important for you to understand this session thoroughly. Okay, so the agenda for this session, as you see, is mainly on design concepts. Okay, and then we will look at how these design concepts help implementing the service oriented architectures. Similarly, how it helps implementing the microservices and how to take a decision between a service oriented versus microservices is what we look into. So while we do that, we will also take industry examples of how this correlates to our actual development work so that we actually see that implemented from the code aspects as well. Okay, and we will also have the demo from both service oriented as well as a microservice architectures perspective. Now session takeaways is obviously understanding of SOA versus microservices decision making and what are the complexity involved while we do follow the design concepts that you will see in that. From the previous session, we already covered a developer standard tools and technology. We will be using some of those tools here. And from there on, I think it's more on how you actually implement that from the code perspective and how the look and feel of that particular architecture is. Okay, from the code perspective. And obviously on the industry, because today each and every solution is based on industry. Okay, so we can have those industry based aspects so that while we design that fits in any particular industry from that particular functionality perspective, right? So let's get started on the what we have today. So bare minimum, you will see today if you are using any of the monolithic application, the business logic and the UI and your data access components, which fits here, the central block, are so tightly coupled that today we will not be able to make out who provides which functionality or even the interdependency between those functionalities. And if this increases further, that means I keep on adding more and more functionalities. It becomes very difficult to see where exactly the business logic is, which are the data access components and so on. So ideally, if you see this from the UI perspective, from the access perspective, or any of the third party communication aspects, caching and database access perspective, everything is so coupled that we are not able to really decide upon how the dependency actually flow, who has which functionality at the end of the day. And the other aspects are obviously the data sources. It may come from SQL, it may come from NoSQL. That integration aspects will still remain same. Similarly, if we are communicating through asynchronous channels like Azure Service Bus or the topics, queues, and all those things, then that remains same. Okay, so if you see, ideally what we are trying to say here is this is what the monolithic architecture is. And if we have the code version of this, this is what look and feel will be. Okay, so here at first place, there is a direct implementation. There is no such a schema or structure already made, which becomes easy for us to understand or maybe enhance that in future. Okay, and as the business logic and the implementation is makes it very difficult, or I would say rather go to the code and find out which service depends or which functionality depends upon which particular service. Okay, similarly from the presentation logic perspective also, if I have more UIs, okay, or the functionality gets added from the various reasons. So I would be obviously going through the code and figuring out what exactly or how they are interrelated together. And this becomes very complex if we don't separate it out, okay, in a appropriate design scenarios, I can say. Okay, so from this monolithic, the challenges which we come across is obviously the business logic, data access and UI, then difficulty to manage the code. Then obviously the business logic is scattered, functionalities are not sure of, like depends upon what specific components, or I would say rather than reading a code to find out how exactly that works. And obviously we cannot test them individually because they are so integrated. It has to be the integration testing to do that end-to-end functionality, or maybe I can do while I develop that in that particular environment or the isolated environment step by step. So these are some issues you can see. And obviously at last you can say from the cloud aspects or from the if I think about the future addition of any functionality, then scalability issues are obviously there. Now, these are the challenges which we face day in, day out with the monolithic architecture. So how do we resolve that? And what are the design aspects which should take care in our day-to-day life? Okay. So first thing is think about the clean architecture. Okay, this is very well defined architecture. Okay, so here, in spite of spreading across your business logic, data access, and the UI, they have separated that with appropriate structure in place. Now, to explain you the structure, consider the middle core, which is an application core. Here, they define interfaces and entities, and then based upon industry or that the domain, you can say we define according to what we need or which functionality we want to have in the application core. Now let's take this with the example. Say suppose we are working in a healthcare industry, hospitals, right? So in hospitals, the entities around which the functionality will be the doctors, the patients, and obviously the healthcare staff which working on these hospitals. And obviously the other entities will be like the operation theaters and all those things, those will be coming in. So interfaces are just the schema which defines what we have to have in a business logic perspective. Okay. Similarly, entities are way around for the functional for which we are designing this functionality. And domain, obviously the aspects which we talked, like it can be any. So in healthcare, it will be health. For insurance, it will be insurance. Similarly, any financial industry or banking, that particular domain will lay here. So what we are trying to say here is, let's define something as core, which is not dependent on anything, which is an application core here. And then based upon that, how we communicate, we also need to have an infrastructure which will talk to the external world, as well as the communication within whatever we defined as a functionality. So that all services will be now taken care by the infrastructure layer. Okay, and obviously we need to have a UIs for different aspects or different entities. So that is where we are mentioning here from a user interface perspective, that will be taken care by this particular layer. So by this, what we are trying to say here is each and every functionality, first of all, should have a schema or structure without direct implementation of them. Okay, so that will be taken care at application core. Okay, so we define them with the interfaces and the entities. Now, once it comes to actual implementation, we will call them as a services. Okay, so that is what we say, like while we implement that, the actual code does not know what is getting implemented, it just knows the schema of that. And finally, when we communicate with an outside, there should be something for us through which we can enhance this communication towards an external dependencies or external world. So that we do with the infrastructure layer. Now let's see how this translates toward even different design aspects. Now here we were more focused on service-based implementations, right? So this is what we will have: core, infra, and UI, and the whole world revolves around that. And that is how we communicate to the external world. Now what happens if this is further broken down in a task-based implementation, which we call microservices. So here, taking exactly the same design principle, if you come down here, the domain, here the example is of e-commerce. Okay, so think of a microservices from an e-commerce background. What we will have within that. Now, each and every task, what we talked about is called the bounded context. Okay, each and every task which we implement is called bounded context. So we start with domain, which is e-commerce. That is a subject expert on, or I would say from that particular industry per se. Then we come to the subdomain. Now subdomain can be your core, which we, the way we say, the application core and the relevant support functionalities, the relevant generic functionality. That it naming can be anything which is relevant for that domain or industry. However, what we want to say here is these particular functionality based driven task, okay, functionally based driven task is now in that particular context, which we call the bounded context. Now, in spite of having this implementation, we are even breaking this down in sub architectures. That means now product catalog can have its own architecture. The orders can have its own architecture. Payment can have its own architecture. So what is the use of that? The use of that, now they are not dependent on one particular technology which was tied to the core. They can scale, or I would say they are now free to, from the flexibility perspective, choose any particular technology framework on which they feel that is the best for that particular task to be performed. Okay, so that is where we are now dividing them in a bounded context, which is nothing but the task-based implementation of these services, which we call microservice. Okay, so I will just pause here for a while so that you can look at these. So these are, if you follow these two principles, you are good on service oriented architectures as well as microservices. So I will just pause here for a while. This is also called the onion architectures because the evolution is core will not have any dependencies, then infrastructure will have dependency on this. Similarly, UI obviously will have come through infrastructure and come to an application core, or it can come directly to the application core as well. So in spite of all the dependencies in scattered around, we are now fixing the core of how the dependency will flow. So this is very useful in terms of while you design the service oriented architecture. Also, to give you a good example, if you are consuming any of the cloud services, infra as a service, platform as a service, or the software as a service, those are very good example of how you define the service oriented architectures. Similarly, DBaaS as a service can also be considered as a service oriented architecture. Now, how do we, as I said, from microservices perspective, how do we really decide whether to go for service oriented or microservices? Both are having good advantage, both are getting scalability. Now it depends upon the complexity. The example which I have taken for healthcare industry, a hospital fits very well in service oriented because it does not have those much interfaces or moving parts from the microservice implementation perspective. So it can fit well within the service oriented architectures. But think of if I have to club all the hospitals chain, then obviously that scale which I need is from the microservice aspects perspective. Because here I'm considering more than 100 plus functionalities, integration, different vendors providing the equipments to the hospitals. There can be n number of things you can think of from the functionality perspective. So as and when the dependencies of the functionality increase, it really becomes difficult even for a service oriented architectures to handle that. Now, then we need a microservice approach so that anything what we do can be taken care within that functionality itself, so that whenever I say that this is a sub architecture or that functionality related architecture that is tied to itself, I know if someone looks, even if someone new comes to this, that person knows that yes, for this functionality everything is here itself. Only thing now I have to know is how they communicate with each other. That is not a big job. I think we can make out once we see the microservice architecture. But at this point of time, I hope this particular structure of clean architecture as well as domain driven design, that is a triple D, is clear from the functionality perspective. Okay, now let's look at from the service oriented architecture itself, how this fits in the different blocks which I've shown you in the monolithic. So as I said, the core will fit here. From the interface perspective, from the entities, you call it as a schema. And then based on that, the services which does not depend on anyone, you implement these services as well as here. Now, how do we communicate is through this particular infrastructure to the outside world. So anything from the caching, your service bus, your data access implementations will come here. Okay, and then obviously the blue one which you see at the top is the UI layer, where you have different view models and the views and the controllers in this particular clean architecture. Okay, so this is the functional diagram from the clean architecture design principle perspective. Rest all remains same, which you have seen from SQL and NoSQL perspective, and other communications obviously happen over that particular APIs. Okay, so this particular is more organized compared to what we have seen from a monolithic perspective. I know where the dependency is flowing and how do I actually enhance this further. If I have to add a schema, I just need to make sure I have the relevant entities and the interfaces defined. Then after that, I have to make those service implementations. So everyone knows what is there as is state, and then look at to be state. Similarly, if you see from the solution structure perspective, this is how the look and feel will be. Now the projects which we were talking before were previously scattered around. Now here it is purely on application core, which gives me a business and application model. Similarly, infrastructure gives me a data access, and also the other services from the caching perspective will be implemented here, and the UI or the presentation logic comes here. And at finally, if you see from an automatic testing perspective, then, or I would say an individual testing, unit testing, integration testing, everything can be done from this particular service oriented architecture. Okay, so this is what you see from the code aspects. So while I show you the demo, I think you will be able to make out like how this is also working at the back. Okay, so bear with me for the demo. We will look into these particular things in the demo as well. Okay, so again, I will just pause here for a while so that you can look at this architecture. And there, as we are distributing this, you will see aggregates. Okay, so this is nothing but in spite of sending the APIs all over the place, we aggregate them, or I would say one functionality taking care responsibility of that. Yes, I would communicate with the different services and provide you the output from that. Okay, so that is how the communication happens across aggregates. So ideally, both service-oriented architectures as well as microservices have a similar nature. The implementation methodologies are different to fit the scale. We come to the code part now. Okay, so moving towards the microservices. Again, if you see the each and every functionality remains in the context. Okay, so which we call the bounded context. It will have complete functionality of presentation UI as well as the data access. It is an individual service now which can scale and don't have any dependency on any other services. So you can see all those microservices here. Now, for me to actually tie or communicate to all of them, I would need some technology in place. Okay, so that is where you see the service bus. The intercommunication within the service happen through this event bus. Okay, now how do I reach this from an external world? Using the API gateways. Okay, so based upon the policies hardening as well as the feature sets which you want to expose, you can have one or multiple gateways based upon the use case you are working on. Here we have three different UIs which can be our traditional web apps. It can also work with the microservices, or they can themselves be the microservices as well. Okay, so this all UI can also be the microservices. The way if you see this demo, everything is while I show you the demo, everything is implemented as a microservice approach, including the API gateways. Okay, so this is what the structure will be while you do the microservice design. So remember again the two principles. First of all, clean architectures. Dependency should be clearly defined. The business logic, data access, and your UI should be identifiable, and you are able to make sure while you scale or add the functionality, you are able to expand that solution is what we require. Okay, similarly, if you see these all from the project aspects, what we see from the code perspective, now everything is in a form of the services which are microservice. So basket, catalog, identity, ordering, payment, webhooks, including the web apps, which we will see in the demo as well, and the API gateways, everything can be a microservice or individual functionality taken care by the respective technology frameworks. So now you are free to choose from, irrespective of that one particular stack, you are free to choose from any stack. So that is what the advantage you get. However, as I said, everything has the reverse advantage as well as disadvantages. So the complexity of microservice is at the higher end, unless and until you really feel that whether it is sufficient for you to handle using service oriented architectures, do that first. And if you really need a scale of, I would say, at least 50 plus or near to 100 microservices or the service oriented functionalities, then only go for the microservices, because obviously you need to justify the cost, you need to justify the equipments being used in that, and obviously the management efforts. So that is the most looked at, how much efforts go in making or adding the new service or new functionality. So you have to think about these two design principles of clean architectures and the domain driven design, which will be very helpful while you design this end to end. Okay, so from here on, I think let's move on to the actual demos. Okay, right now this is the clean architecture, okay, for e-commerce application which we have seen. Now if you see application core have the entities defined. Okay, similarly I have the interfaces of what I intend to do. So that is the business logic we have. Okay, so each and everything what you see here from the, they just are the skeletons. Okay, now moving further, you see the infrastructure layer. It has a data access components. Now, important thing to note here is while you implement the database as a container, you also have to take care of seeding that, because container cannot live 24/7 unless and until I think if you are running same at 24/7, there's no need of container. You have to separate your database in a external service, which we have been talking since beginning. So remember, that is the reason you never see databases implemented in a container in a production environment, because of the ACID nature which we require for the database related transactions. If you think this is just for test and development, you can go with a container, but from the production aspects, keep the database in a separate platform as a service layer so that you can use them for actual database scenarios, because database does not is meant for microservice. Okay, so remember these things while you design your infrastructure for that particular functionality. Okay, now also, okay, I do the coring, I have the infrastructure layer, but how do I expose? So for that, we also have a public API layer, which ties these services or communicates with the help of the API, which we call as open API or the Swagger. Okay, so that is how the communication happens. And then finally, we also have the web layer, which provides us the actual implementation of UI, which we'll look into. Now to implement this, you can directly go and publish this on any of the platform. Okay, so you can do that directly from here. If you are using Visual Studio, okay, you can directly go click on new and select the respective service to which you want to publish. Or if you want to run locally on your machine, the way I did was I did on the cloud as well as did on locally on my machine. I had this Docker desktop installed. So if I have to run this through this console, I can just directly go to the command prompt, okay, of my Cloud Shell. And in interest of time, I've already built those images, so I'm not going to build, but for you, the steps will be Docker compose, Docker compose build. Okay, this will build out the images that will be available to you in the Docker desktop. And then following on, you can just click on the Docker compose up. This is these all things are already set up in Docker compose.yaml file, which will help you to get this up and running from this the web application which you're trying to build. Okay, so while I click on Docker compose up, it will go and see the images are there and try to get all of the services up. If you see what is running as of now, it is now trying to seed the database, because obviously container cannot hold whatever the data in it. That is the reason it requires the seeding of that particular databases. Okay, so that is the reason I was saying for production, make sure you have the external service in a platform to be used as database, or if you are comfortable with infra as a service on VM or something, you can host there. But obviously the communication methodology you have to decide based upon that. Okay, now let's look into how this works. Now, as of now, these three are running for me, so I can directly go and browse that. Let me browse the first MVC app. Okay, so this is the actual UI, and you can also try the login as well. In this particular UI, they have also given the actual demo user as well as the password for it, which you can try logging to this eShop application. Click on the space. Okay, so I'm in here. So whatever the basket I want to add, this is nothing but in our actual production scenario, this will be your Redis cache or equivalent services. Okay, and you can just update the quantity, okay, and go on to the checkout. And if you are sure, just pay towards that, and that is how your order is confirmed. So while this functionality is now built from the demo aspects, but it fits well in our actual e-commerce industry as well. Okay, so now also, as I said, like we can also check for the APIs. So before I actually go to even actual proper, I can also go and check the APIs. So how those APIs looks like now. You know, these APIs are available from an OPN, so you have to append a Swagger to that. Okay, so this is what I am doing as of now. I can get the brands. What exactly? So these are exactly what you see on the categories. Okay, so if you see the UI and go back to the and you see the UI, this is what you see from the brand aspects. Okay, and from here I'm just trying to take the API layer so that I can check really I'm able to fetch those details from the database. Okay, so this is what the functionality you see from the web aspects. Now, while this moves towards the microservice aspect, exactly the same use case. So there I want to show you exactly how this changes from the code aspects as well as how it changed from the UI aspects. So let me move on to there as well. Okay, so here again, just summarizing this, what we had is the important three services: application core, public API, and the web is what we are looking at. Okay, so this is more towards the business logic, and these are the APIs and web. These what you see is the functionality of how the page look and feel which you want to design. Okay, so this is again the internal layer to how you're designing the pages with Razor. Okay, so the Blazor, I think there is a different architecture for that, which is more towards the dynamic creation of the websites. Okay, so Blazor is towards that. But at the end of the day, application core, infrastructure, APIs, and web is what you will look end to end. Okay, and then let me show you the actual. I'm just stopping this on this how I implemented this on the cloud as well before we move to the microservices. So on cloud aspects, so here is the look and feel of this deployment. Okay, so I have the front end UI. I also have the API layer towards, and obviously the two database is available as form of a SQL database hosted on Azure SQL. Okay, as a platform as a service. Now I can just go and browse this. Exactly the same look and feel which you have seen in the Docker implementation. Okay, so exactly look and feel, login and everything same. So as I said, important thing to look at is how the complexity changes. Now, if you see this, this is just a service oriented architecture using the clean architecture design principle, and you have these 3 or 4 projects. Now I'm just changing it to microservices on containers. Okay, just see the projects, because now each of the functionality is a microservice. It has to take care of it from the business, from data access, as well as the UI perspective. Now everything here comes in a services aspects, and following on, you will see more. They can be traditional apps or they can be microservices, whereas in our case we have even deployed API gateways as a microservices. So this is what the change is while you move from a service oriented towards microservices. Production use case purely depends upon really how many services or functionality, or is there any scale aspects or additional functionality happening at any future. So as I said clearly, healthcare industry designing just for a hospital is sits well in a service oriented architecture. However, if I move with the chain of hospitals, then obviously I have to think a microservice approach based on the complexity involved and the future growth of that particular functionality. Okay, so the decision purely depends upon the business or customer, the way they want to invest in that technology. Okay. Now, as I move to the container, similar case, I can just just implement this in a same format, build as well as uh, the build as well as the Docker compose up. As this takes 15 to 20 minutes for the images to build, again here also I just uh, design this or created the images so that I can just show you the how this particular microservices can be get up in a short point of time. Okay, so just wait for it to load. We close out the other windows not required. So until it comes, I think for each of the services, you will see the API. Okay, the reason that is now they are independent services, so they need to expose the APIs. That is how they will communicate. Also, if you see our architecture as well, while I was showing you the actual architecture diagram, we had a complete communication using the service bus, and then obviously towards the UI, and we have the API gateways actually bringing in all the UI related requests. Okay, so again, this while you implement this, you go to the source and just make sure Docker again compose and up, bring those services up. Okay, so this will start. I think meanwhile I can also show you. I think there is some problem with port being already allocated. Yeah, this is. I think this you have to take care while you uh, actually run the multiple container environments here. So some port is getting blocked. So I have to figure it out. What choose that? 6379. This one. So I have to stop whichever is running for that. Let me stop this. Okay, so once it stops, I think I have a complete set of containers which is running for. We can stop this. But let me show you this. I think in a while I implemented this on AKS, so that will be faster, so that we get a good time for Q&A. Okay, so let me show you the cluster. So from microservices, this is what the services while you deploy this on AKS. So exactly the same services which you see in the Docker. These are the namespaces in which the microservice is installed. Workloads. As each services is having an API layer, you will see a completeness of each and every in its own with the relevant namespaces. Okay, as it's the development environment, we even got the SQL and NoSQL in this as a container, but not recommended for the production. Similarly, if I have to connect to this particular services, I can go and check for the cluster IP, and obviously from the ingress perspective, I get the URL which maps this to the IP addresses. Okay, so let me look into from the first of all, let me check the status. Okay, so with this, I can check the status of the APIs. Okay, so this is what the health of each APIs. Similarly, if I want to again check out the So here, if you have noted in our architecture diagram, we have two implementation. One was for single page application, which runs at the root without appending any web MVC. So this is what is the implementation or UI for that, exactly the same website. Now other UI was using our traditional web MVC running in the containers. So functionality again is same. You have to click on log on and it will give you the identity for you to test this out. But at the end of the day, two again design principles, service, the clean architecture, and obviously the domain driven design. Okay, so rest all remain same. Add click out cart and then go to that cart, order that particular. There are some more details here. Click on place order. This is how it looks like from the your own order management. Okay, and finally you can log out. So moving back, a few things to note here is one, obviously, if you are going in a production ready scenario, the application gateway again will be kind of not a microservice. It can be a platform as a service. You have to think about the integration layers, and because obviously everything is now API, you should be able to take care of that. Okay. Similarly, on the node pools, based upon you need to have the automated scaling of these along with the horizontal pod scalers, which you will obviously take care of, and obviously the namespaces, the way you want to segregate these resources in it.